Hello everyone, welcome to day 4. Today we're going to be going over inverse trig functions and their derivatives. We're going to start by going over the graph of these functions. Okay, so in order to work with inverse functions for these trig functions, we restrict the domain so that the function itself within this domain is 1 to 1. If you remember, the original sine function looks something like this, right? So it doesn't pass that vertical line test. So that is why we restrict it in this domain, so that for every input you have exactly one output. And so we restrict the domain to negative pi over 2 to pi over 2. And you could see that the range is going to be from negative 1 to 1. And so the inverse function is going to have the domain of negative 1 to 1 and the range from negative pi over 2 to pi over 2. And the same idea here, working with the cosine function, we restrict the domain from 0 to pi so that it's 1 to 1 on its domain, and to work with the inverse function. And then for inverse function is going to have domain negative 1 to 1 and range 0 to pi. And here are the graphs of our tangent and inverse tan functions. As you could see, we do have two asymptotes from negative pi over 2 to pi over 2. And then for the inverse functions, we have two horizontal asymptotes. And now here are the derivatives of each of these inverse functions. So I would recommend memorizing these three on this side. The derivative of inverse sine, secant, and tan, because then and here are the derivatives of the inverse functions. I would recommend memorizing the derivatives of inverse sine, secant, and tan, because their cofunctions are the same, just with a negative, an added negative, right? So these are important to memorize, and here are the integrals, which I would also recommend memorizing. These are the three forms that would give you inverse tan, sine, and secant as the integrand. Okay, so now let's start with some examples. So let's find the inverse of the radical 3 over 2. And so what this is asking is what input gives you this value here. So in order to do this, we use the triangles, the 30, 60, 90, and the 45, 45, 90. I also recommend memorizing these as well. Opposite the 30, you have a 1. Opposite the 60, you have a radical 3. And then you have 2 here on the hypotenuse, and then 1, 1, radical 2 for the 44, 45, 45, 90. And so we know sine is opposite over hypotenuse, so which angle here will give you radical 3 over 2? So here's the radical 3, and here's the 2. So radical 3 is opposite the 60. So sine of 60 is radical 3 over 2. So that's how we know inverse sine is 60 degrees. And we write it in radians. So 60 degrees in radians is pi over 3. And now let's do this one, the cosine. So which angle gives you 1/2? Cosine is adjacent over hypotenuse. So we want 1 over 2, so adjacent to 60. So that's also going to be pi over 3. Okay, now let's get the derivative of this function here. So y prime is equal to, so we need to memorize the derivative of the inverse tan, and that is equal to what I had showed before, is 1 over 1 plus x squared, okay? So the x here is square root of x minus 6. So I'm going to plug that in. 1 plus x squared, so square root of x minus 6 squared. And then using chain rule, I need to get the derivative of this. I write it in this exponent form. And the derivative of this is 1/2. I bring the 1/2 to the front, subtract 1. And that's going to be negative 1/2. And now we just simplify, so this cancels here. So we have 1 over 1 plus x minus 6 times 1 over 2. This is on the bottom because it's a negative. So it's the square root, right? And then this is going to be 1 over 1 minus 6 is negative 5. So x minus 5 times 2 square root of x minus 6. So it's going to be 1 over x minus 5 times 2 times the square root of x minus 6. Oops, let me bring that 2 to the front. And then that is your answer. Okay, now this problem here is asking us to find the limit. So I'm going to draw the graph of the inverse tan. If you remember, this is pi over 2. And negative pi over 2 are its asymptotes. Okay. And so first, let's see what this value here approaches as x approaches infinity. So e to the power of x, as x gets larger and larger, this whole value is going to get larger and larger, right? Because it's 2.7 something to the 2 to 3 to 4 all the way to infinity. This is going to approach infinity, right? So this is going to be infinity, approaching infinity. And so as we approach infinity on the arctan or inverse tan function, we are approaching pi over 2. So this is going to be equal to pi over 2. Okay, now let's find this integral. So this is in the format, if you notice, this is du over a minus a squared minus u squared. Okay, so we want to use this, and we know that this is equal to sine negative 1 u over a plus c. So we notice that this integral here has a similar format. So that's how we know that it's going to be an inverse sine once we evaluate it. So let's identify the u. So the u here is what is being squared. It's not the 16, right? This, I'm going to rewrite it. It's 1 minus, this is a 4x here, right? And then, so u is 4x, du is 4 dx. And then a is 1. Okay. And so now I'm going to, here, I'm going to move the 4 to the front, divide by 4, so that I could just substitute in for the dx. Minus 4x squared, right? And this is u, right? Or u. I'm going to write a u also. Okay. And now I'm going to bring this to the front. Okay, and now I could evaluate it. Now I know that this is going to be sine negative 1. U over a, u is 4x. Over a is 1, so that's just a 4x plus c. And then I have the 1/4 in the front. Okay, and that was a quick review on inverse trig functions and their derivatives. I'll see you all tomorrow.